Isn't the phase shift just left and right?
Yes, but it has some interesting consequences, especially when combined with the period. That's where we're going to have the interesting things happen. So, this is also why phase shift typically comes beforehand. So, as a reminder of our 5 steps. Step 1, make sure to analyze our particular functions. A, sine of bx minus c plus d, or a cosine of bx minus c plus d. Begin by analyzing them. Step 2, determine where the midline is and graph it. Step 3, determine how the amplitude works and where to graph it. Step 4, phase shift. And finally, after phase shift, 5, period. The reason we do state phase shift before the period is because the phase shift has some unique consequences for the period. Remember, the definition of period will come into play quite a bit today. That's because period is defined as distance from the start to the end. If it is 2 pi, that does not mean it will end at 2 pi. It means it will end 2 pi after it begins. If it says the period is pi, that does not mean it will end at pi. It means it will end 1 pi after it ends. So, let's take a look at our function and remind ourselves the midline based upon d, amplitude, absolute value of a, the phase shift, c over b, and finally the period, 2 pi over b. Let's take a look. Our first function, we're going to just do ones that do just phase shifts to start off with, and then we'll add in the other functions as we go, things like midline, amplitude, and other pieces. Let's do it. Let's begin by graphing the function sine of x plus pi over 2. So, sine of x plus pi over 2. It's very important that you take a look at this function and analyze it by its parts as we go through this. So we'll start with the same question we did before. I'll start by drawing a similar picture. There we go. Let's do one piece at a time. All right. We have questions about the midline. We have questions about the amplitude. We have questions about the phase shift. And we have questions about the period. So, as we discussed before, I'm going to make a list of things over here. Some homework questions ask you to list out all the pieces like this. And so I'm just prepping for that kind of question. All right, let's do it. Midline. This function, where's the midline? To 0. So it'll be on the x-axis. Remember, for the 0, it's on the x-axis. Anything else, it's above or below the x-axis. So that means my middle of this function is going to be right on the x-axis. My amplitude. What is my amplitude for this function? 1. So I can go up 1. I'm going to call this 1. That negative 1. My amplitude is 1. So it is 1 up from the midline and 1 down from the midline. Next question, phase shift. Don't be freaked out. Listen to the function. It is supposed to be b of x minus c, and the phase shift is c over b. So for this problem, what is my phase shift? Left pi over 2. It ends up being negative pi over 2, but the negative just means go to the left. So, left pi over 2. That means normally I'd start on the origin. But instead I'm going to move it left pi over 2. So we're going over here to negative pi over 2. And that is where it's going to start now. So my phase shift, negative pi over 2. Or you might say left. I love the way you said that, Garrett. I'll try to do both from now on. Okay? Last question, period. What's the period for this problem? 2 pi, that's right, Ebony. Now what that means is this function will end 2 pi later. So now I ask, where will this function end?
Negative pi over 2 plus 2 pi.
Yes. Define where this thing ends. So this is a little thing I did not show you guys yet because it's better to understand it when you do it the phase shift. For sine, it will always start at the following points. The phase shift, comma, the midline. If you know what the phase shift is, and you know what the midline is, it will always start at that point. So let me verify that real quick. My phase shift is negative pi over 2, or left pi over 2. My midline is on the x-axis, which is 0. So my first point is at negative pi over 2, 0. Where will it end? It will end on the point phase shift plus period, comma, m. If you are a formula person, there is a formula to find all 5 of the points we've talked about so far. Scott already hinted at part of it, where we use the 1/4, half, and 3/4. This is the other piece. You may always determine the start and the finish using the phase shift, the period, and for sine, the midline. For cosine, these two are slightly different. You don't have to use these. I never do. I just remember how we define sine and the phase shift. So when I approach this problem, I don't think about those two formulas. I think, okay, I'm starting at negative pi over 2. It will end 1 period later. So for me, I think, okay, 1 period is 2 pi, so that's half a pi. I have another half a pi. And then a full pi after that. Down here at 3 pi over 2. So this thing will end 2 pi later. Like I said, these formulas are fine. I find that trig can turn into just a lot of formulas. A lot of formulas. I like the concept better this time. I like to think to myself, okay, where's the phase shift? Now just add the period on. That's how far it goes to the right. Okay. So I now know where it starts and I know where it finishes. I'm going to scroll down just a little bit to give you some room to work with here so I can make my little table like I did before. Go right here. Okay, my table was X, Y,
Z.
Yeah. Let's see what you did there. Okay. This thing is going to start at negative pi over 2, comma, 0. It's going to end at positive 3 pi over 2, 0. Okay. Let's look at the pieces. Next thing I'm going to ask. Sine does something unique in the middle. It crosses the midline again. Remember, sine starts in the midline, usually climbs up, comes back to the midline, falls down, comes back to the midline. It follows that nice arcing pattern. It starts in the middle, ends in the middle, ends in the middle, in the middle. But my middle has shifted. Because I shifted my entire thing pi over 2 to the left, my middle is now actually right here. Halfway between negative pi over 2 and 3 pi over 2. So at pi over 2 is where this thing crosses the axis. Okay? And at the 1/4 and 3/4 marks, it does two other things. At the 1/4 mark, halfway between the halfway, it hits its maximum, the amplitude. But now that happens halfway between negative pi over 2 and positive pi over 2, which is here at 0. So my point is at 0, 1.
I did something wrong. I didn't know my graph too big.
Possibly. With the phase shift causes the most complications because it can move it to the left, it can move it to the right. It has the most complicated aspects to it. You have to be very careful and get the beginning and the end in the right spot if you're going to do this. Okay, so again, go through that process. We determine the beginning by using the phase shift and the midline. We determine the end by adding a period and using the midline. We use the middle, because it's sine, to put it on the midline again at pi over 2. We use the middle of the middle, using that first quarter, to put it at 0, 1. And now we use the second middle of the middle to determine at pi, we should be at negative 1. Take a look. Take a look. Look what I see. Excuse me. Last thing. Can I rest? There's my function. Now again, this is one period of it. So there'll be another one to the left of this, another one to the right of it that match it perfectly. So you could copy this thing and paste it right here and have 2 of them. You copy this thing and paste it over here and have 3 of them. But remember, this is just the first primary period, the main period. Alright, let's remind ourselves. We began by identifying all the same components we had before. Midline, amplitude, phase shift, period. Where it has a little twist is that phase shift moves it left and right, which causes the period to do some interesting things. So we started by graphing the 2 main parts the same, midline and amplitude. And then there we transitioned forward and we said, okay, with those 2, now we do the phase shift. Phase shift picks the graph up and moves it either left or right. In this case, it moved it left, pi over 2. Once it was moved, we then took the next phase. Let's take that function and then move it left or right. But it also moves the period. Because the period is based upon where it starts and where it finishes, how long that distance is. In this case, it's still pi over 2, it just left a little bit. Still traveling the full pi over 2. After that, we use the same rules we did yesterday. Determining the middle to find the min segment, and then our 2 pieces on the amplitude, because it's sine. All of today will be spent where every single problem has phase shift. I want to do at least 1 or 2 more where it's just a phase shift, and then we'll start add another piece in. Maybe change the midline. Maybe change the amplitude. Maybe change the period. If you take a look at your homework, most of the problems have 1 or 2 changes. So the problems we're going to do in class are going to end up being hard. I want you to be prepared for them. Again, you need to be prepared to do any one of these 4 or any combination of them. Let's look at the next one. For the next one, let's see. We're going to do cosine of x minus pi over 6. You'll notice these are typically weird values. They typically are radian values. Pi over 6 is a nice radian value because it helps to do the period with weirder values. Again, the period is based upon a 2 pi variation. So having it in this form is actually really helpful as opposed to having it like as a 3. As it turns out, it is easier by far to graph cosine of x minus pi over 6 than it is to graph cosine of x minus 2. It is far easier to do the pi over 6 because of how the period works. Alright, I'm going to label my pieces and start my table. So I have the midline, I have the amplitude, I have the phase shift. I have a period. And now, my table. X, Y.
It looks like the following
Dear Lord.
attendance has not been posted. Mr. Beeston, Mr. Douglas, Ms.
I never post
Ellis,
attendance.
Mr. Hessman, Mr. King, Mr. Snyder,
Never attendance.
and Ms. Bader. Please make sure those posted. Thank you.
Okay. Just like before, I'm going to start by looking at these one piece at a time. For each one of these to begin with, only a phase shift change. So, midline?
0.
0. X-axis. Amplitude? 1. Phase shift? I'm just going to list them all out to begin with. Phase shift. Pi over 6. Which means to the right. Pi over 6 is a positive value. And the period? 2 pi. All right.
2 pi after.
After the pi over 6. Yep. All right, let's start this off. The first couple pieces are same as last time. Okay, so midline. It's right there.
Beautiful.
Amplitude. Here at positive 1.
Beautiful.
There at negative 1. I know, Cole. I've been practicing.
For how many years?
Not enough years, apparently. Need more practice. Okay, phase shift. As Levi correctly pointed out, it is pi over 6, which means it is right pi over 6. So we're going to go to the right a little bit. For my pi over 6. Now, don't forget, cosine
Goes down.
starts at the top. When instead of starting at the origin and at 1, it's going to start at the phase shift and at 1. So right there. The phase shift at the top amplitude. Which means my starting value in this case is pi over 6, comma 1. All right, my end value. Well, I should know it's going to end on 1 because it's cosine, right? It'll end back on top. But what's the x value? I got to add 2 pi to this thing. So I'm currently at pi over 6. I got to add 2 pi to this to get to my new ending location. If I add 2 pi to pi over 6, what do I get? That's right, Madeline. 13 pi over 6. Let's come over here. 13 pi over 6. And again, it's going to be at the top. So right there. All right. Where this gets kind of fun is finding these x values. Because again, you're dealing with fractions for a lot of these pieces. Let's take it nice and slow. Call them out when you know them. All right, so cosine starts high, ends high. We've got the 2 points listed in our table. Let's go for the middle piece. The middle piece for cosine starts high, ends high. In the middle, it hits the bottom. So visually, I know I go to the middle of this picture. I go to the bottom. It should be right there, which tells me the y value is negative 1. But what's the x value?
13 pi over 12. 3 pi over 2.
Both incorrect. 7 pi over 6 is correct. Ebony, would you like to tell us how you got that solution? Little truth to that statement, probably. So, did you use that formula I showed last time, the middle formula? That's fantastic. Because it's going to be halfway in between, right? Yeah, that's exactly what Scott was doing too. That works great when the period is 2 pi. Fantastic. Okay. Okay.
Let's
Well done.
Why would you do it with the period?
Say again, sorry, Mel.
What's the formula again?
The formula is an average formula from geometry and from algebra. So what I would do is I would plug in, to find this middle number, I'd plug in pi over 6 plus 13 pi over 6 all over 2. Pi over 6 and 13 pi over 6 would be 14 pi over 6 all over 2, which becomes 7 pi over 6.
So multiplying by 1/2 doesn't work.
Nah, sadly. It works well when there isn't a phase shift.
This was like a base.
Yep. Like I said, the phase shift just throws a lot of stuff into the air. Like you have to figure out the pieces. The phase shift is by far the hardest one. That's why we saved it for last. Make sure the other ones we're doing okay on. It's the hardest one. It's also the lowest numbered one in your homework. Okay, that's why we got to spend some time on it. It's not one that's common, but you got to know it. So, again, here I'm now at 7 pi over 6. All right. We got 2 points left to find. We know where it starts. We know where it finishes. We know what happens in the middle. Goes and does 2 more things. It hits the mid segments, this midline, in 2 spots. One here on the left. Halfway in between, and one there on the right. So I know the y values, they're in the middle, they're in the midlines, that'd be 0 and 0. But the x values, those are a little bit tougher. 4 pi over 6? You mean 3 pi over 2? I got 2 pi over 3 as well.
I'll say that would reduce.
Want to double check that there, Hayden?
That would reduce down to 2 pi over 3, so it's correct.
2 pi over 3 or 4 pi over 6? Yes, it reduces down. Either's fine. What I like to do for these ones is I'll count everything out like I would in an algebra class. I'd count up, I'd do about like pi's over 6. So I'd put up here and be like, okay, I know it starts at pi over 6, so let's make this one 2 pi over 6. This would be 3 pi over 6, 4 pi over 6, 5 pi over 6. Just find a system that works for me. Something. Okay? 2 pi over 3, yep. Okay. And the last one. 7 pi over 6. Wait, what did I do? 2 pi over 3. There we go. So that means this dot is at 2 pi over 3. What about that dot?
Something weird.
Something weird. It's definitely weird. So I'll show you how I find it. Again, I use the midpoint rule that I'm going to use right here. I do the same thing, but I'm going to do it with these two. This dead center of those two, right? So I would do 7 pi over 6 plus 13 pi over 6 all over 2. 7 and 13 makes 20 pi over 6 all over 2. 20 pi over 6, I can take a 2 out, meaning I get 10 pi over 6, which becomes 5 pi over 3.
So to find any midline, we can use that a plus b over 2.
That's what I do. But I'm fine using a formula, and I can do it quickly in my head. That's why I use it.
You wouldn't simplify the whole fraction?
I did.
Top,
The 2 cancels the 20 to become a 10. And the 2 from the 6 becomes a 5.
Never mind. You just wait till there.
Yes. That's how I was taught, so it's a little weird for me. But yes, this should be at 5 pi over 3. Out of all the parts of this problem, this is the hardest when you have a phase shift. I can tell you in your homework, the single hardest problem you will find, and look for it, you'll find one, I think. There's one that has both a period change and a phase shift. Because they just have weird fractions for all their answers. But again, if you follow the process will at least get you the picture right. Finding individual values just takes a formula that you can use, or a thought process you can use. Scott and Ebony have both mentioned some things they've tried, little tricks, and they've been successful. So try out your own thing and make sure you find a value that makes sense in the context. Alright. For this next one, I'm going to do another phase shift problem. This time I'm going to show one technique that I've tried in the past in order to make graphing these a little easier, where I actually do it more like an algebra problem, where I count out by values. So I put like 1, 2, 3, 4, 5, and 6. So I do them in a weird way. So take a look. Next one. Whew. Sine of x plus pi over 4. Sine of x plus pi over 4. Okay, you're going to see a slight variation on what I do, not in the stuff to the right, but in when I make my graph, I'm going to do something really special to help make the grid a little easier to work with. It's a small change, but it can help fix that last step that we kind of struggled with, finding those values. And so if you like it, you're welcome to use it. If you don't, we still showed a few other techniques you can try to make sure to get those values. Use what you feel is necessary. All right. Okay. Midline. X-axis or 0. I can't. That's x-axis. Amplitude.
1.
Beautiful.
Pi over 4. Negative pi over 4.
Negative pi over 4. Remember, the formula is bx minus c, so if it's plus, it becomes a negative. Negative pi over 4. Which tells me this is going to go left pi over 4. And the period? 2 pi. All right. Okay, midline. Amplitude. That's at 1 and negative 1. Okay. Phase shift. We move it left, pi over 4. So count over, pi over 4. It's left, so it's negative. And I drop my dot. Now, this is a technique I like to do if I have to make a really accurate graph. I think it works great. What I'm going to do is I'm going to take my period. I'm going to break it apart in the same way the phase shift is broken apart. Right now, our period is 2 pi, right? But my phase shift is pi over 4. Those aren't very easy to relate to each other. What I'm going to do is I'm going to take this 2 pi, I'm going to convert it into pi's over 4. In this case, 2 pi is 8 pi over 4. Why would I do that? Because now I can count 8 units to the right of this dot and place my ending point. Now again, this works really well if you know what the phase shift is and are willing to convert the period. Again, I used the 2 pi from the period for this problem, converted it into the same units that the phase shift is in, and now I can count this out nicely. I count 8 units to the right, because this is 1, gets me there, 2, so that would be at pi over 4, 3, that's going to be 2 pi over 4, which would actually be pi over 2, 4, at 3 pi over 4, 5, at pi, 6, at 5 pi over 4, 7, at, that would be 6 pi over 4, which would be 3 pi over 2, and then 8 at 7 pi over 4. So what I did was, as I went to the right, I just simplified each time I went to the right. So take a look. Negative pi over 4. Add pi over 4 to the right, that'd be at 0. Add another pi over 4, I'm at pi over 4. Another pi over 4 would be at 2 pi over 4, but 2 over 4 is 1/2. Add another pi over 4 would be at 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. I have gone 8 units to the right. It's an alternative method that some people like and are like, okay, I get it, I understand it, and some people are like, what are you doing, buddy? I give it up to you. I think it works nicely. Some people just look at it and are like, I'd rather do it the old way and suffer in silence. It's up to you. But my dot should be all the way down here at 7 pi over 4, because that is 2 pi to the right. Where this is also helpful is it's a little easier to determine where the middle is now, because you can count your way to the middle as opposed to estimating your way to the middle. So you can come here and be like, okay, the middle of 8 would be 4 and 4. So the middle would be 1, 2, 3, 4. So you can tell it's dead center. And I can see I've already had that marked. It's 3 pi over 4.
Don't you need the thing to be 8 pi over 4?
It is. From here to there is 8 pi over 4. See, I have 1 pi over 4, 2 pi over 3, 3 pi over 4, 4, 5, 6, 7, 8 pi over 4. I have gone 8 pi over 4 to the right.
So
It's weird because I started at negative pi over 4. So the numbers look a little funny when I do that, but it does work. I have gone 8 pi over 4 to the right. This is my middle. Should have been at negative pi over 4. 0. My end at 7 pi over 4. 0. My middle, 3 pi over 4. 0. And I can do my middles again. Middle of these two is right here, which would be on top. Middle of these two would be right there, which should be on bottom. And I've got my beautiful function. Sorry, and I'm slipping it to the end really quick here.
Nice.
I know. Look.
I'm confused. Is
One
mine?
second.
Is my quarter?
I'd love to hear what you just said. I couldn't focus all day. What'd you
My
say?
quarter lines up. It's supposed to be pi over 4. Because
Yeah.
I counted 8 from both of them. I put 7
I-
4, but it's
Yeah.
at 0. That's supposed to be 1.
So I told you guys before, like, algebra is kind of random, sporadic. You pick kind of random numbers, plug them in, hope they work. This one follows a process, but that process, it's got a lot of pieces and they have to be done right.
Add power 4.
Like I said, I use this technique whenever I'm graphing by hand because to me it makes a lot of sense to convert your period into the same as a phase shift to count everything out well. Some people look at this again and they just look at it and they don't get it. And I respect that. You've got to find a way to find these values. I've given you a formula way you can do it. I've given you a counting technique you can try out. And maybe you find something that somebody else has tried. I strongly encourage, if you are struggling with this section, you have a weekend to work on it before we talk about this again on Monday. There are thousands of videos out there that will showcase other people's ideas of how to go through this process. They probably have different opinions on what order you should go in and how to do it. Maybe theirs is better than mine. I am one person, I can't know everything. Maybe you come in on Monday like, Douglas, I learned it this way for the weekend. I'll be like, I'm going to teach it that way from now on because it's clearly better than what I'm doing. Okay? But you're responsible for being able to graph these by the end of next week. Whatever it's going to take to get us from there, from where we're currently at, to that point, I'm willing to try what I can, but I'm one person. The more you can help yourself, the better it's going to be for you in the long run. Right? You're the one who's got to do it. So, and if you find something that you find is helpful, show me. I love to see it because I want to get better too. All right? This is a tough time for everybody every year, and I want to make it better. All right? So again, the first 3, in my opinion, once you get used to the process, straightforward. Midline, amplitude, period. They got some tricks to them, they got some weird pieces to them, but they're doable. This one is a tough one. Let's do another. Alright? Let's check it out. We're going to be like Wiz Khalifa. Another one. No? 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 I worked hard on that joke, man. That was just for you.
Set it up for you.
Thank you. Alright.
About 5 minutes.
Work done. Sorry.
There we go. Most of your homework problems are either one change or two changes. Let's do 2 changes. I will do my best to do it in time. Let's do it. Midline. Amplitude. Phase shift. Period. Here's my graph. Okay. One piece at a time. Stretch it out, shake it out. Let's go. Look at your numbers. Look at your problem. Let's answer these pieces one piece at a time. As we answer them, I'll put them in the picture. Where's the midline? 0. X-axis.
3.
Amplitude? 3. Hold up right there. Let me put that in. Midline. Amplitude. At +3 above and -3 below. Remember, the midline is how far away, or sorry, the amplitude is how far it is away from the midline. Phase shift. That's right. In pi/3, which means it is right. pi/3. Let's go to the picture. I go to the right pi/3. Why not? Let's claim it's right there. Okay. The period. Period. 2 pi. All right. So, any technique you want to use, but tell me, where is this going to end? 7 pi/3 is the correct solution. Very nice, Evan. Very nice. So pi/3, 2, 3, 4, 5, 6, 7. I apologize if you said it too. I heard Evan. Okay, so we got pi/3 and 7 pi/3. All right, cosine starts on the amplitude and ends on the amplitude. Let's throw that up here. Right there. And right there. Halfway in between, it drops to the bottom. Halfway between these two, it's right there. What's the x value there? 4 pi/3. Now, those 3 are easy. The other 2 are a little tougher. We go to the middles of these 2, putting a dot right there, and a dot right there. I now know what the graph looks like. What are my values? All right, this first missing dot right here. So it's halfway between pi/3 and 4 pi/3.
So, yeah.
Yep. So that's what I would do. I would take pi/3 plus 4 pi/3 and then divide it by 2. That's kind of tough, but I believe the solution should be 5 pi/6. Calculator's your friend here. 5 pi/6. And the other one, as it turns out, should be at 11 pi/6. There's my graph. So beautiful. Sublime. Amazing. Wonderful. In all the right ways. To finish, I will, once everybody has a chance to take a look, I will be putting this on decimals so we can verify all these numbers. Because this is right. Let's do it. My function is 3 cosine of x minus pi/3. Easy, man. You have your time. Do not block my screen. Alright. You go to Desmos. My function was. Yep, don't forget, seminar is next. It is Friday. Oh my gosh, I ran out of time. I'll put it up here. Those of you walking out, take a look. I'll see you guys on Monday. Don't forget your homework assignment over the weekend.
Last Friday of the month. Or the first.
Look at that. Picture perfect values.
Oh, I know I'm gonna find these values. I'm used to
That's nice. Told you you're welcome to check them. You'll live.
Why do we have to not do this? What's it like?
Trig, remember how I told you before? If you're taking a trig class, it's because most of the time it's assumed you're going to go higher, right? I will tell you to make sure you get called a slope.
I was walking.
You cannot possibly compensate back every function already is just very slow.
What's slope period for though? I have to do that on a day-to-day basis and try to
You know what you use? Yeah. You know what you use slope yields for?
Huh?
They're airflow over foil. They're airflow around your car.
Why don't they make computers do all that?
They do, most of the time.
Exactly.
Kids. Trig's too hard. I'm graphing functions. I don't like to type now. I want to grab a function.
I just needed to drawing them. I just didn't because I couldn't do it. I mean, I could do it. It just looked like
Yeah.
not great. I'm so hungry, but I've been terrified to eat all day.
Ugh. Wow, that was cold. Whew. Okay. Should probably stop the recording.